change. So let's have a run and see. Okay, so here is our chart. Okay, nicely drawn out. Yep. So we have control over almost every aspect of it. And if this is taking up too much, we can always remove the year and just show the month dash date. Yeah, we can also do that and then have a look like this, right? So we have very, very good control on all aspects computationally. What I mean by that is we don't need to how should we put it, calculate, oh, where's the x and y position of this 0408, and then think about how to rotate the font so that it is 180 or sorry 90 degrees rotated, and all the little details, and then think about, oh, let's find a nice font size because it's too big, too small, not nice. Let's adjust the axis. Can we find this baseline here? Where's the XY position? Put a 0 there. All these are too much details for us, overwhelming us, when all we want is to make a high level decision. Should we buy or sell the stock, right? So based on all this information. All right. So you see that very quickly once you have understood the sort of pain or sensitive areas in manipulating the dot plot and then orchestrating them to show this kind of multi-plots, then things become very simple, really easy. Okay, then next we want to do subplots. Okay, subplots just means that in one figure we have 6 plots, remember? So irregardless of the tools, IPython console and graphs, right? Under that control settings, irregardless of the size, the DPI, the width height that we set, this will be the actual width height that is used by Python and PyPlot. All right, if we specify that here. So the tools preferences are to control this chart here. This chart can be big and small. It's determined by Spider, not our program. This specification here is completely determined by our program. All right, and it will overwrite that of the Spider. So we'll see a very, very huge chart. And then we say we want 6 axes, 6 graphs, oriented in 2 rows by 3 columns. Okay, then we plot, 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 and the rest are simple. Just repeat more of the same, right? And at this point in our calculation, because we added the weight moving average and exponential smoothing, we have 6 columns. So just nice. So let's run it and uh, compare it with our commands and see how we derive them. Okay, so here very nicely we have 6 charts. Okay, and it is being oriented in ABD. Remember this ABD? All right, so it is 0, 0, 0, 1. Row number 0, column number 0. Row number 0, column number 1. Okay, row number 0, column number 2. So it is always presented as a list of lists. And if we print out axis, sorry, we see a list. All right, where is it? A list, right, of 2 lists. This is one list of 3 items, and second list again of 3 items. And this array here is actually NumPy's array. NumPy's sort of 2-dimensional array. We can always convert that into Python's list, but that's only the outer layer. So the first layer is Python's list. Second layer is still NumPy's list. We'll have to do a list comprehension to convert. But actually we don't. We can just directly index it as if they were Python's list. Okay, and I think we illustrated quite a number of these, and AX6 is actually exactly axis row 1, column 2, like this. So here. Okay, so far so good. Now let's try and run our. So this is really huge because it's 9 inches by 6 inches. okay, inside our spider plot, not in the actual figure. Now let's try to configure it as 6 by 1 and see. So this is a bit of a detour, right? So change from our classroom slides. Just for sake of understanding, what is it going to look like? Yeah, not very nice, right? So 6 rows by 1 column. So we have 6 rows. And we can try again, 1 column by 6 rows. 1 row by 6 columns. Let me clear all the charts, or else I may get some warning. Okay. All right, again, we are being shown with this, and it's not really that sensational. So it's better to stick with the original orchestration to make sure that we have decent size of the axis to display. All right. Now, the last part is to make sure we can capture it as a file. To do that, let me call upon my Windows Explorer to show you this directory here. So I created this temporary directory d:temp python, and I need to make sure that spider is also equally tuned in. All right, so to temp python, so that when we create any saving of file, by default it is saved into that file. So let's check again. Current working directory. Yes, it's correct. So this will confirm that anytime we save some figures, if we don't specify the absolute path, like C colon or D colon, then it will be saved directly into the current working directory, which is what we want. So please make sure you get that. Now, if you get CWD and it is not showing a temp directory that you intend to save it in, then what you can do is you can chdir into d colon, or maybe your Mac case is slash user slash something, then just do accordingly. All right, pi on this. All right, so you can always do it directly using OS. Okay, so we have just inserted the last few lines to save figure in outfig.pdf. Then with the exactly, so this is AX6. What is AX6? AX6 is this subplot, right? And we can run get figure. Oh, actually, by default it shows up as a chart. So this get figure is a function, and figure itself is also a function. I hope we can see. We cannot see. You cannot see. So figure itself is also a function, basically the same function. Figure can save fig, right? Only figures can save fig. What AS6 dot get figure, what it does is this gets back our figure, Then from there on, it's figure dot save fig. So it's the same mechanism. So let's run it. And I do want, how should we do it? Okay, so let me try to squeeze a little bit in to review our df plot here. Okay, so now watch that I have only one file, and let me clear all the plots, and we don't need that big a space for the program because we all are clear. Now we run it, we should see 1, 2, 3, 4 new files being produced here towards the end. And why are we not seeing anything here? Okay, it's because I think that when we run it, it has reset to the original current directory. So that's fine. We can always impose, right? So we will import OS and set it directory. Because I haven't saved this, and when my configuration is such that Spider will save any file unspecified into the current TMP, not my TEMP directory. So it will save into the same directory as per my program's directory, which is tmp. So, well, we can always chdir into force it into the directory that we want. So this is a bit unexpected, but it's fine. So let's force it and change directory into that and then start saving, right? So let me clear everything again and let me clear the whole console. Then at least if there's some information, we can get to see that. Ready? Go. Yeah, exactly. The working directory was TMP. So here we see 4 new files. Exactly the file names that we produce. But are they valid files? Can we actually see them? Of course, right? So, well, it's created in my other screen, but I can bring it up here. So this is .jpg, and clearly we can interchange my email attachments, thumb drives, Dropbox cloud storage, whatnot, show this. There's a PNG file here, right? We can also import it into our PowerPoint or MS Word, include in our reports. Then there's a TIFF, which this photos application can show, and that's about it. I think that's wide enough a variety. And if we double left click on the PDF, my Acrobat reader actually can read this chart pretty nicely. But remember, this is A4 size landscape, so it's very large. You may or may not want this, but definitely can produce, right? So that's all we have. All right, good. I think by now we have covered everything. I hope you are very excited to see all these because it has now vastly enlarged our ability to present data, uh, partner our eyes to seek out more pattern and more interesting aspects of the data, and definitely it's making us a lot more capable in terms of processing data analytics than before today's lesson. So, okay, so see you in the next lesson on how we can use Seaborn and also Pillow to really, really juice up our ability to visualize data.